Welcome to qnawire.
In this question, we're given a ductile wire, a ductile metal wire, which means that you can stretch it without breaking it. It has a resistance R, and you're told that the length is stretched from the original length L to 3 times L. So let's go ahead and write the new length, which we'll call L prime, is 3L. You're also told that the density and resistivity remains constant as you stretch this wire. So actually the density remaining constant is a critical point. We're actually going to make use of this fact explicitly. And you're also told that the amount of metal in the wire stays the same, so it doesn't change as you're stretching it. And they want to know what is the resistance now after you've stretched this wire. So if you're stretching the wire, obviously the length is going to go up, but then the cross-sectional area of the wire will actually decrease. So with the information that we have on hand, the equation that we'll use to solve this problem. So we have a resistance, we have length, but we don't have resistivity, but we actually don't need a particular value for it, as you'll see, because we can find stuff in terms of R and L and resistivity. So we can use equation 2510, which says that the resistance is the resistivity times the length divided by the cross-sectional area. Right. So let's say this is for the original unstretched wire, and now for the stretched wire, let's call that resistance R prime. Well, we're told the resistivity stays the same as you stretch it, so it's this still the same row, but the length is now the new length, which is 3L, and the area, the cross-sectional area, is A prime, but we don't know what A prime is. But we're told that the amount of metal doesn't change and that the density stays the same. So if that's the case, then the density D prime is equal to the original density D, and if the amount of metal is not changing, then we have the definition of the density, mass over volume, prime is equal to mass over volume. And since the amount is not changing, then the mass stays the same, and then the volume, this means that the volume also stays the same. So V prime equals V. And what we have now from this part of the equation, that the prime volume is equal to the prime volume, by using the definition of the volume, L prime A prime is equal to L8. Right, so that's the length times the cross-sectional area. But we know that L prime is 3 times L, so we're given 3L times A prime is equal to LA, or that the new area, A prime, is equal to 1/3 of the original area. Okay, so the original cross-sectional area. And now we can use A prime that we just found in this equation right here. So let's do that on the next page. So R prime is equal to rho L prime over A prime, which is equal to rho. And this is, we found, or we're told that it's 3 times L, and we found that A prime is 1/3 of A. So then if we just kind of simplify this a little bit, we have 9 times rho times L divided by A. And this part is nothing more than the original resistance itself by definition of equation 25.10. So we have that the new resistance, the resistance of the stretch wire, is 9 times the initial resistance of the unstretched wire.